I am starting this video with the sets and set operations. I have this set of numbers. I call this A. So this is set A. These numbers are called the elements of the set. This is another set. I call this B. So this is set B. Next I am combining the two sets. That is, I am putting together all the elements of these two sets. These are the elements of set A. Now add these elements. This 4 is already here, so don't repeat. 5 is already here. 6 is not here, so add 6. This 9 is already here. This 10 is not here, so put the 10. This is called A union B. We write A union B as A, the symbol B. This is the symbol for union. So this is A union B. If you take any element in A union B, that element is in A or in B or in both. For this reason, this A union B is also called A or B. Next, I am taking the elements that are in both A and B. This 4 is here and here, comma. This 5 is here and here. This 9 is here and here. So these are the elements that are in both A and B. We call this set A intersection B. We write A intersection B as A, the symbol B. This is A intersection B. A intersection B is also called A and B because any element in A intersection B is both in A and in B. In this problem, there are three sets: set A, set B, and set C. You need to find A union B, A intersection B, and A intersection C. First, A union B. For A union B, you need to combine the elements of set A and set B, but no repeat of elements. So combine the elements of set A and set B. First put the elements of set A. Now add the elements of set B. This B is already here, so don't put it again. E is not here, so add E. G is already here. I is not here, so add I. This K is already here. This is A union B. You can also write these elements in the alphabetical order, that is B, C, D, E, F, G, I, K. Both are correct. You can leave it like this or write in the alphabetical order. Next, A intersection B. A intersection B is the set of elements that are in both set A and set B. That is, you need to write the common elements of set A and set B. B is here and here, write that. C is here but not here. D is here, not here. F is here, not here. G is here and here, write that. K is here and here, write that. This is A intersection B. Next, A intersection C. A intersection C is a set of elements that are in both set A and C. That is, you need to write the common elements of set A and set C. But none of these elements are in this set. So, this is an empty set. Is equal to, this is the symbol for empty set. This video is about a compound inequality. So what is a compound inequality? A compound inequality is two inequalities connected by an or, and operator. This is a compound inequality because there are two inequalities connected by an or. This is another compound inequality. Here, two inequalities are connected by an and. In this problem, there is a compound inequality. In the compound inequality, two inequalities are connected by an or. You need to draw the graph of this compound inequality and write the solution in interval notation. First, draw the graph of this inequality. Go to 94. There is no equal sign, so put an open circle. This is less than, so draw a line all the way to negative infinity. This is the graph of this inequality. Next, draw the graph of this inequality. Go to 95. There is an equal sign, so put a filled circle. This is greater than, so draw a line all the way to positive infinity. This is the graph of this inequality. This or means union. So you need to combine the graphs. The two graphs together fill the entire number line. So if you combine the two graphs, you get this graph. This is the graph of this compound inequality. So next we write the interval notation of this graph. The smallest number is negative infinity, comma, the largest number is infinity. Put a parenthesis for negative infinity and a parenthesis for positive infinity. This is the interval notation of the solution. Next, we are going to draw the graph of this compound inequality and write the solution in interval notation. First, draw the graph of this inequality. Go to 3. There is an equal sign, so put a filled circle. There is greater than, so draw a line all the way to positive infinity. Next, draw the graph of this inequality. Go to 91. There is no equal sign, so put an open circle. There is less than, so draw a line all the way to negative infinity. This or means union, so you need to combine these two graphs. If you combine these two graphs, you get this graph. This is the graph of this compound inequality. Next, we need to write this graph in interval notation. There is a gap in the graph. So first write the interval notation of this part negative infinity, comma, negative 1. Put a parenthesis for negative infinity. So this is open circle. So you need to put a parenthesis for negative 1. Now put the union symbol because we are going to combine these two parts. Now write the interval notation of this part. 3, comma, infinity. This is filled circle. So you need to put a bracket for 3. For infinity, put a parenthesis. This is the interval notation of the solution. In this compound inequality, two inequalities are connected by an AND. You need to draw the graph of this compound inequality and write the solution in the interval notation. First, draw the graph of this inequality. Go to 0. There is an equal sign, so put a filled circle. There is greater than, so draw a line all the way to positive infinity. Next, draw the graph of this inequality. Go to 2. There is an equal sign, so put a filled circle. There is less than, so draw a line all the way to negative infinity. This AND means intersection. For intersection, you need to take the overlapping region of the two graphs. The two graphs overlap in this region. So draw the overlapping region. There is a filled circle, put that. There is another filled circle, put that. This is the graph of this compound inequality. So next we need to write the graph in interval notation. In the graph, 0 is the smallest number, 2 is the largest number. Filled circle, put a bracket. Filled circle, put a bracket. This is the interval notation of the solution. Next, we are going to draw the graph of this compound inequality. First, to draw the graph of this inequality, go to 6. There is an equal sign, so put a filled circle. There is greater than, so draw a line all the way to positive infinity. Next, to draw the graph of this inequality. Go to 1. No equal sign, so put an open circle. Less than, draw a line all the way to negative infinity. And is intersection. So you need to take the overlapping region of the two graphs. The two graphs do not overlap. So you get an empty graph. So this empty graph is the graph of this compound inequality. Empty graph means the compound inequality has no solution. Next, the interval notation. The interval notation for no solution is the symbol. In this problem, there is a compound inequality. You need to solve this compound inequality and draw the graph of the solution and write the solution in interval notation. Solving this compound inequality is solving these two inequalities. Solving is isolating the variable. So you need to isolate the variable y in this inequality and isolate the variable y in this inequality. First, let us solve this inequality. The variable y is in this term, so you need to isolate this term by moving this term to the right. Negative 3y greater than 4. Negative 5, so you need to add positive 5. Negative 3y greater than 4 plus 5 is 9. Now divide both sides by -3 and isolate y. You get y. You are dividing this inequality by a negative number, so you need to reverse the inequality sign. This is greater than, so you need to put less than. 9 divided by -3. Y less than 9 divided by -3 is -3. Now you need to solve this inequality. Put the r, isolate this term by moving this term to the right. -y less than or equal to 6. This is positive 4, so you need to add -4. -y less than or equal to 6 minus 4 is 2. Negative y is -1y. Now divide both sides by -1 and isolate y. You are dividing this inequality by a negative number, so you need to reverse the inequality sign. This is less than or equal, so you need to put greater than or equal. 2 divided by -1. Y greater than or equal 2 divided by -1 is 92. Put the r. This is the solution of this compound inequality. Next, we need to draw the graph of the solution. That is, you need to draw the graph of this compound inequality. First, to draw the graph of this inequality. This is the graph of this inequality. Now draw the graph of this inequality. This is the graph of this inequality. There is r, so you need to combine the two graphs. If you combine these two graphs, you get this graph. This is the graph of the solution. Next, we need to write the solution in interval notation. There is a gap in the graph, so write the interval notation of this part. You get this. Now put the union symbol because R is union. Now write the interval notation of this part. That is this. This is the interval notation of this part. This is the interval notation of the solution. This is the last problem. We are going to solve this compound inequality and draw the graph of the solution and write the solution in interval notation. First, we solve this inequality. Divide both sides by -4 and isolate x. You get x. You are dividing this inequality by a negative number, so you need to reverse the inequality sign. This is less than, so you need to put greater than. 12 divided by -4. X greater than 12 divided by -4 is -3. This is the solution to this inequality. Put the and. Now solve this inequality. Isolate this term by moving this term to the right. 2x greater than or equal to 14. Positive 10, so you need to add -10. 2x greater than or equal to 14 minus 10 is 4. Now divide both sides by 2 and isolate x. You get x greater than or equal to 4 divided by 2. X greater than or equal to 4 divided by 2 is 2. So you have this inequality, this and this inequality. This is the solution of this compound inequality. Next, we need to draw the graph of the solution. First, draw the graph of this inequality. Now draw the graph of this inequality. There is an and, so you need to take the overlapping region of the two graphs. This is the overlapping region of the two graphs. Draw the overlapping region. There is a filled circle, so put that. This is the graph of the solution. Next, we need to write the interval notation. The interval notation of this graph is 2, infinity. This is filled circle, so put a bracket. For infinity, put a parenthesis. This is the interval notation of the solution.